Hi everyone, let's start lecture 9, which is about clustering. In this lecture, we will have the clustering method and its application on the datasets of WHO, MovieLens, and Netflix. This lecture will be presented in 4 parts, and this is the first part. On the course map, we are right here, lecture 9, clustering and its application on the cases of WHO, Netflix, and MovieLens. The clustering method is in the category of unsupervised learning. In supervised learning, as you remember, we had an outcome or dependent variable. And in building our predictive model, we need to minimize the prediction of the outcome variable based on the independent variables, right? And so by having that dependent variable, we call those methods as supervised learning. But in unsupervised learning, we don't have any outcome or dependent variable. So in clustering, there is no outcome or dependent variable, and we want to segment the data in similar groups. That's the main goal in clustering. So we are not going to build a prediction. We are not going to have a predictive model. We just want to segment our data into similar groups like this. As you see here in this example, we are segmenting the data into similar groups. Okay. The applications of clustering could be in market segmentation, document clustering, image segmentation, social network analysis, and so on. Okay. If we have a large data set, maybe it's better to cluster the data set into similar groups and then apply a predictive model. So if we need to apply predictive model, then we can combine clustering with a predictive model. So first we cluster our data set into similar smaller groups, and then for each group we'll build a predictive model. So this will work better in large data sets, but for smaller data sets, we may end up with overfitting. So it's not recommended to use clustering and predictive models for smaller data sets. So yeah, we will see an example later in our course on this approach. I mean, combining clustering and predictive models. Okay. Here we have an example. We are grouping the points into 3 clusters or 3 groups, and our criteria to do so is distance between the points. So here the points are assigned to a group based on how close together they are. Okay. We have different algorithms for clustering, but in this lecture, we're going to cover the hierarchical and k-means algorithms. Okay. The first thing that we need to define in clustering is how we are going to measure the distance between the 2 data points in our data set. The most popular one is Euclidean distance. So in Euclidean distance, the distance between points I and J will be measured by this equation. Okay, so here the K is the number of variables or features that we have in our data set, and so we will measure the distance between each 2 rows or data points by this equation. Okay. Let's have an example here. In the MovieLens dataset, for each movie, we have a vector of binary variables 0 or 1. The features or variables here are the categories of the movies like the adventure, animation, children's, and so on. Okay, so for example, for Toy Story, it takes value 1 for the categories of adventure, animation, children's, comedy, and fantasy. Okay, and for the movie of Batman Forever, it takes the value 1 in the variables of action, adventure, comedy, and crime, and for the rest it would be 0. So here we have two vectors of 0 and 1 values, and then we can uh, uh, define or obtain the distance between these two movies. So let's do this. So here we have the vectors for the two movies, and so we can easily calculate the distance between these two movies by the equation of Euclidean measure. Okay, so in this application, we can interpret the value here, the value of the distance, as the square root of the number of genres in which they differ. Okay. We have other distance metrics which are popular as well, like Manhattan distance. In Manhattan distance, we take the sum of absolute values instead of squares. So the distance between the two data points of I and J would be the sum over K, the features or variables, and the absolute value of the distance xik and xjk. Okay. The next method is maximum coordinate distance. Here, for each group or cluster, we calculate the maximum distance between the data points. Okay, so usually in each group we have multiple data points, right? So we take the distance between each pair of the data points, and then the maximum one would be our measure here. And the third one would be non-similarity score. So here we obtain the number of features for which the two vectors differ. Okay, so this method would work well with a category called features, where we have many possible values like the director. Okay, but I can say the most popular one is the Euclidean measure and then Manhattan distance. Okay. We also need to measure the distance between clusters. Here, in order to be able to measure distance between two clusters, first we need to obtain the centroid of each cluster. And then we'll measure the distance between the centroids. And we can use the Euclidean or, for example, Manhattan distance to do so. So in order to obtain the centroid of each cluster, the centroid would be the point which has the average of all data points in that cluster. So that means we have, let's say, for example, the X bar as the centroid of each cluster, and it would be 1 over m sum over I going from 1 to m x I 1. This is for feature 1 or variable 1. And then for the second variable, we do the same. Here we assume that we have m data points in the cluster, and we are taking the average over m data points on for every feature, every variable. Okay, xi2, and then for the last feature, 1 over m xip. Okay, so this would be our centroid for the cluster. Okay. We also have different measures for the distance between clusters beside the centroid distance. We can consider the minimum distance between two clusters. So the distance between clusters is the distance between points that are the closest, like this. As you see here, let me show here. So between this and this cluster, we are taking the minimum distance, right? We find the 2 points that are so closer than other points in these two clusters. And also in here for these two clusters, this is the minimum distance, right? And also here, okay? And also we can consider the maximum distance between two clusters. So yeah, we can obtain the centroids and then go with the measure of distance between the centroids, or we can consider the minimum distance between the two clusters or the maximum distance. Okay. The next thing before applying a clustering method we need to consider here is to see if we need to normalize our data. If we have different scales in our variables or features, then that different scales could have great impact on the measure of distance. So if we have different scales, then we need to normalize our data before applying the clustering method. In our example that we had here for the movie dataset, since all genre variables are on the same scale, I mean, we have just the values of 0 or 1, right? So for this dataset, we don't need to normalize our data. But if we include a variable such as box office revenue, then we would need to normalize our data. Let's have an example here by assuming revenue of the movies in our variable set. So here we have 4 movies, and 2 of them are in the action genre. Let me show here. Yeah, these 2 movies are in the action genre and these 2 are not. Okay. In terms of the revenue, if we consider the revenue in millions, then here we have $0.8 million and $1.2 million, and again 1.3 and 0.9. Okay, so if we consider the unit in $1,000,000 and we have the numbers in our revenue column or variable as 0.8, 0.9, 1.2, and 1.3, then that wouldn't have that much impact on clustering, and we will have the 2 movies of genre in a cluster, in same cluster. So if you want to have 2 clusters here, the 2 action movies would be in same cluster. Okay, but here let's assume the revenue is in thousands. Okay, so as you see here, the scale of the numbers here are is in 600, 700, but in $1,000. So if we don't normalize our data and we have the scales here, so by having this scales and the scale of 0 and 1 for being in action genre, as you see here, the 2 more expensive movies would be in same cluster, right? See, so that means here action doesn't really matter because it's too small in terms of the size or distance compared to the revenue numbers, right? As you see here, 600 and so on. So this shows that if we have different scales, then we need to normalize our data to eliminate the impact of scales in our clustering. Okay.